So we now move on to the next part of the chapter, that is nuclear fusion. So we saw the nuclear fission and the radioactive part in the first part, and now we see the nuclear fusion. Fusion means combining. So that is nuclear fusion. Nuclear fusion is the process in which two light nuclei combine to form a heavy nucleus. Okay, when two light nuclei combine to form a heavy nucleus, it is called as nuclear fusion. In this process also, huge amount of energy is released. So yeah, whenever it is fission or fusion, in both the cases there is a huge amount of energy which is going to be released. So here we see that the nuclear fusion reaction, there is a huge amount of energy released. The reason for the release of energy is that the mass of the product nuclei is less than the mass of the sum of the masses of the two combining nuclei. This loss in mass is released in the form of energy according to the mass energy equivalence reaction, E is equals to delta mc squared. So yes, the same way as in the nuclear fission, that the sum of the masses of the reactants and the products, or we can say the before the nuclear reaction taking place and after the nuclear reaction, is not the same. There is a loss of mass, and that loss of mass causes the change, that is the amount of energy released, because the mass is getting converted into energy by the formula E is equals to delta mc square. Example, when two deuterium nuclei, that is 2H1, fuse, 3.3 mega electron volt energy is released, and the nucleus of helium isotope 3 helium-2 is formed. This helium isotope again gets fused with one deuterium nucleus to form helium nucleus 4He2, and 18.3 mega electron volt energy is released in this process. The nuclear reactions are as follows. So they are saying that if I take two deuterium, so what are deuterium? Deuterium are nothing but 2H1 plus 2H1. Now when they are combining, they are going to form into 3He2, okay, plus 1 neutron. This is what is going to happen, and they are going to release about 3.3 mega electron volt of energy. Now this, when further it is going to be fused with hydrogen, so it will be 3,2He plus 2H1. They are going to form into 4He2, that is a pure helium. So helium is going to be formed plus one hydrogen atom, and that is proton, and plus it will be giving you 18.3 mega electron volt. So this is what is going to happen over here, that the reaction will be with two deuterium, okay, will give you one isotope of helium plus neutron plus 3.3 mega electron volts of energy. This, when it's combined again with another deuterium, it is giving you helium plus protonium, that is hydrogen, normal hydrogen, and 18.3 mega electron volts of energy. Thus in all, 3 deuterium nuclei fuses to form a helium atom with a release of 21.6 mega electron volt energy. A part of this energy is obtained in the form of kinetic energy of neutrons and proton, that is 1H1. So you can see that over here, in this case, the total energy what we are getting is 21.6 mega electron volt. End result will be, we are getting one helium atom, okay, plus one hydrogen. So the end result is one neutron. We are getting one neutron, one proton, and one helium atom. Other examples will be proton plus proton will give you deuterium plus 0.42 mega electron volt. 2 deuterium giving you tritium plus proton plus 4 mega electron volt. 2 deuterium, 1 deuterium giving you helium with 1 neutron and 17.6. 2 deuterium giving 1 helium per neutron, that is 3.3. 2 helium with deuterium giving you helium plus proton, 18.3. I think you can just learn this part. No need of the other reactions, because this is the most important one. So you can see nuclear fusion is not possible at ordinary temperature and pressure condition. Now this is the biggest issue with nuclear fusion. See, it will be known that nuclear fusion, as on date, we are not using nuclear fusion for energy source anywhere. Okay, we are not using this thing. It is found only in the sun. This kind of reactions takes place inside the sun, and the sun is radiating a huge amount of energy because of this. So we are trying to make such a kind of a thing where hydrogen can be combined to give you helium and give you energy, but this requires a very high temperature and pressure conditions, and because of this very high temperature and pressure conditions requirement, it is not possible to use this particular kind of method for our regular energy source. So the reason is that when two nuclei approach each other, due to their positive charge, the electrostatic force of repulsion between them becomes so strong, too strong, that they do not fuse. It's so obvious. One nucleus which is having protons, another nucleus which is having protons, अगर हम लोग दोनों को combine करने के जाएंगे तो definitely the repulsion will be so high that it cannot be fused together. So we will require too much of temperature and pressure conditions so that they can fuse together. The energy which is the repulsive force which is there between them, it has to be overcoming that, only then they can be fused together. So that is the main difficulty in case of nuclear fusion. Hence, to make the fusion produce possible, a temperature of 10 raised to 7 Kelvin, okay, 10 raised to 7 Kelvin, huge, and high pressure is required. At such a high pressure, both nuclei, due to their thermal agitation, acquire sufficient energy so as to overcome the force of repulsion between them when they approach each other, and so they get fused. This is why the fusion reaction is also called as thermonuclear reaction. Okay, so you can see that it requires a huge amount of temperature. 10 raised to 7 Kelvin is a very huge temperature, very difficult to achieve, and only at that particular temperature the kinetic energy which is present between the two is going to be so high that it could overcome the repulsive force and could fuse together. So note, the source of energy of the sun and the stars is a nuclear reaction fusion of light nuclei such as hydrogen present in the inner part at a very high temperature, 10 raised to 7 Kelvin, and high pressure, as a result of which helium nucleus is formed with a release of tremendous amount of energy. The reaction is 1H plus 1H plus 1H plus 1H is going to be 4He plus 2 beta particles plus 2V plus energy. Not required to learn. Thus in this process, 4 hydrogen nuclei fuse to form a helium nucleus with a release of 26.7 mega electron volt energy. The working of the hydrogen bomb is based on the nuclear fusion, in which a high temperature 10 raised to 7 Kelvin required for the fusion reaction is obtained by the bombardment of the nuclear bomb. So you are taking a nuclear bomb, उसके bomb के reaction से जो high amount of heat energy generate होगा, उससे हम लोग fusion करेंगे. That is what is the hydrogen bomb using the principle as. Although it appears that the energy released in the nuclear fusion is much less than that released by the nuclear fission, but indeed it is not so. Now this is something which you need to understand properly. What we understood up till now was that if I take the case of nuclear fission, at the time of nuclear fission, we came to know that the amount of energy which is generated by 1 AMU was approximately 190 mega electron volts. So 1 AMU was equal to 190 mega electron volt. Okay, whereas when I am taking over here that of the helium, so it is something like that if I take only one hydrogen over here, so कितना 2 AMU जो है, it is giving you about 21 mega electron volt. So even not even that much, so something less than this. तो हम लोग क्या लगेगा कि इसके केस में we are not getting much amount of energy formed over here. But in this case, you can see that here when you are taking 1 AMU, that 1 AMU के लिए तुम लोग ने क्या लिया? You took uranium 235. Okay, so the mass what you have taken for the fuel is so high. What is the mass you have taken for this? So small. Okay, just 4. So we can see that 4 mass gives you 21, whereas here 235 gives you 190. Okay, that's the main difference between the two. So here the mass required of the fuel in case of fission is much more. So for a bigger mass you get 190 mega electron volt, and here for a very small mass you are getting 21 megavolts. So automatically if I take that much mass of this, it will give you tremendous amount of energy. So that's why it is seen that fission does not give you that much amount of energy as compared to the fusion. Fusion gives you more amount of energy, and another advantage is that the end product of the fission are simple helium and hydrogen, which can be there in the atmosphere without any problem. So it is not causing any kind of a harmful effects. So although it appears that the energy released in the nuclear fusion is much less than that released in nuclear fission, but indeed it is not so. For a given mass, the energy released due to fusion of the light nuclei is much more than the energy released due to fission of the same mass of heavy nucleus. The reason is that for the same mass, the number of light molecules nucleus is much more than the number of heavy nucleus. So if I am taking just one simple mass, message now, I am taking a mass of 235. So what is the number of uranium I am taking? I am just taking one uranium. If I am taking 235 of hydrogen, I will be getting around 100 and something number of particles. So अगर मैं 100 लूँगा तो automatically इसको 100 से multiply करेंगे तो कितना ज़्यादा energy हो जाएगा. That is the difference between the two. Hence, the energy obtained per unit mass in fusion is much larger than the energy obtained per unit mass of fission. This is why scientists are engaged in getting energy by the process of fusion of deuterium, which can be obtained in abundance from the seawater at a very low cost. Because deuterium is available in the seawater, you can easily get that thing, and at a very low cost we are able to generate a huge amount of energy. But the main difficulty is 10⁷ Kelvin. But the main difficulty is that at 10⁷ Kelvin, the substance gets ionized, that is, it is in the plasma state, and it is very difficult to store it. Nowadays, efforts are being made to preserve the substance in plasma state with the help of nanocarbon tubes. So that's a new technology trying to be imposed, that we are trying to form the plasma state of hydrogen so that it can be used for fusion. So now let's see the last part of the chapter, that is the differentiation between nuclear fission and fusion. Very very important part, one of the ऐसा shortest questions करके आ सकता है कि इसके अंदर कोई पूछ सकता है easily, सब जो regularly पूछते हैं, that is this part. Okay, so nuclear fission and nuclear fusion का differentiation. In fission, when neutrons are bombarded on a heavy nucleus, it splits into two nearly equal light fragments. In fusion, at a very high temperature and high pressure, two light nucleus combine to form a heavy nucleus. So इसके अंदर heavy nucleus splitting into two equal parts. Here, two light parts combining to form a heavy part. Nuclear reaction is possible at ordinary temperature and pressure. Here, nuclear fusion, the reaction is possible at a very high temperature, 10⁷ Kelvin, and a very high pressure. Nuclear fission, one nuclear fission reaction, nearly 190 mega electron volt energy is released. One nuclear fusion reaction, nearly 24.7 mega electron volt energy is released. Nuclear fission में, for the same mass, the energy released in the fission process is less than that of the fusion process. For the same mass, the energy released in the fusion process is much more than that of the fission process. The fissionable substance is radioactive, so it gives out harmful radiations and creates problems in disposal of its waste. Whereas fusionable substance is not radioactive, so it does not give out any harmful radiations, and disposal of its waste is also not difficult. Limited amount of fissionable substance is available in nature. See, you know that uranium and all, they are the only few substances which are able to fission. So that's why fissionable material available in the nature is very limited. Whereas fissionable substance is abundance because of the seawater. It is in abundance in fissionable materials available. Fission process can be controlled. Nuclear reactors is based on the controlled fission reaction. Yeah, you can see the controlled and uncontrolled nuclear reactions. So nuclear fission is a controlled reaction, can be controlled, but as fusion reaction cannot be controlled. This is why fusion reactors could not be constructed so far. Nuclear bomb is based on the uncontrolled fission reaction. Hydrogen bomb is based on the uncontrolled fusion reaction. But note that in both the processes, nuclear fission and nuclear fusion, the similarity is the release of energy due to loss in mass. Loss in mass calculation due to m is equal to mc square. So uske hisab se there is energy produced in both the cases. So similarity between the nuclear fission and nuclear fusion is that in both the cases there is a loss of mass due to which there is a generation of energy. So that was about the chapter that is nuclear fusion and fission, and also the chapter of the modern physics based on radioactivity and nuclear. So that is the end of the chapter. Okay. Yeah, the main important part in this particular chapter will be the equations of the fission, the first equation of the fission, the equation of the fusion, the differentiation between radioactive material decay and the nuclear fission, and also the nuclear fission and nuclear fusion differentiation. Okay, so that was the end of the chapter. Thank you.